All right, so today's class in geometry, we are looking at polygons, triangles, and quadrilaterals. So firstly, let's take a look at polygons. A polygon it's a closed figure. It has to have 3 or more sides. So a triangle has 3 sides. That would be the polygon. So the number of sides will also determine its name. All right, so it has to be a closed figure made up of sides and vertices. So here are just some examples of polygons, their number of sides, and some diagrams of what they look like. Make sure you do know these prefixes here, like quad, meaning 4, penta is 5, hexa is 6, hepta 7, octa is 8, nona 9, and then deca is 10-sided. So here we have some regular polygons. When we talk about a regular polygon, it means, again, it's a closed figure. It has to have 3 or more sides where all the sides are congruent, meaning all sides are the same and all the interior angles are also congruent. So if you look at these figures, we have the dashed lines here meaning that all sides are congruent, and then angles are represented here, meaning all angles are congruent as well. So same thing here in all of those figures. So that's a regular polygon. So sometimes you may be asked to draw diagonals in a polygon. So that's when you would join 2 vertices that are not beside each other. So that would be impossible to draw a diagonal in a triangle. So here we can see examples here. So we would draw a diagonal from this vertex to here. That makes 1. From here to here, that makes 2. So this figure here has 2 diagonals. So here, for this figure, how many diagonals does this figure have? So from here to here, that's 1, 2, 3, and then 4, 5, 6, and then we have 7, and we have 8, and one more, 9. So there's 9. If we draw them, we can see that this figure has 9 diagonals that we can draw. But we can also do this using this equation. Number of diagonals is equal to n times, in brackets, n minus 3, and then divided by 2. Okay, so let's use the equation, and let's take a look here for our first one. So n represents number of sides here. We have 1, 2, 3, 4. So our equation would be 4 times 4 minus 3, and then we are dividing by 2. So this makes it 4 minus 3 is 1, divided by 2, and then it becomes 4 divided by 2, which equals 2. So for this figure, like we saw, it has 2 diagonals. It's the same thing when we do the equation method. When we look at this one, this figure has 1, 2, 3, 4, 5, 6, 6 sides. So same thing here, 6, and then 6 minus 3, and then it's divided by 2. 6 minus 3 is 3. 6 times 3 is 18. So 18 divided by 2, and that equals to 9. So 9 diagonals, which is what we saw when we counted those out. So that is how the formula works. So I'll just pause here. All right, so this one here we just did on the previous slide. It's a 6-sided figure, and we saw that it had 9 diagonals, and we also did that with the formula there as well. Here we have a rectangle. It's a 4-sided figure. We can draw 2 diagonals, right, from vertex to vertex. So here's 1, and there's 1. And the formula method would be the exact same what we did here, because it's a 4-sided figure. All right, so just looking at how many diagonals there are in different polygons. So a triangle, there's no diagonals because we cannot connect a vertex to another vertex that's not beside each other. Quadrilaterals, those are four-sided figures. They've got 2 diagonals. Pentagon has 5 diagonals. A hexagon has 9 diagonals, which we saw, and so on. A heptagon has 14. Octagon has 20. A nonagon, which is 9-sided, has 27. A decagon, which is 10-sided, has 35 diagonals. So next we're going to talk about triangles. We're also going to be classifying triangles. So triangles can be classified according to their sides or according to their angles, as we can see in this chart. So if it's according to their sides, we can have an equilateral triangle. All 3 sides are congruent, but at the same time, all angles are congruent as well. They have to be 60 degrees. 60 plus 60 plus 60 to give us 180 degrees for that triangle. An isosceles triangle, 2 sides are congruent. So shown by those double slashed lines here, that means these 2 sides are the exact same in length, and therefore these 2 angles will also be congruent. A scalene triangle, no sides are congruent. So all 3 sides have different measurements, shown by single slashed line, double slashed line, and triple slashed line. That means different measurements for all 3 lines. We can also see that no angles are congruent. Okay, all angles will have a different measurement. And then we have classifying triangles according to their angles. So an acute angle triangle, all angles are going to be less than 90 degrees. An obtuse angle triangle will have one angle. This angle here will be greater than 90 degrees, but less than 180. So this would be an obtuse. It just needs one. As long as one angle is obtuse, we can call that an obtuse angle triangle. And then the right angle triangle, one angle has to be 90 degrees. So it's usually represented by that square in that corner. That means 90 degrees, so a right angle triangle. The angle sum of a triangle, this we've covered before. That just means that in any triangle, the 3 angles will always add up to 180 degrees. So just some examples here. Here we have a right angle triangle. 90 plus 55 plus 35 equals 180 degrees. Here we have an isosceles triangle. So these 2 angles are the same. 72 plus 72 plus 36, 180 degrees. An equilateral triangle, the 3 sides are equal. The 3 angles will always be 60, 60, 60 in an equilateral triangle, which equals to 180 degrees. Here we have a scalene triangle. All angles are different, but when we add them together, they will still add up to 180 degrees. So that's the angle sum of a triangle. So sometimes in a question, you will be given a triangle. You might be given 2 of the angles, and then you have to figure out the 3rd angle. So let's do these examples quickly here. So for this next one here, we have 40 degrees and 40 degrees. So 180 minus 40 minus 40, or you could have just done 180 minus the 80 degrees. So here angle X will equal to 100 degrees. And last one here, remember that this little square means 90 degrees. So we're going to take 180 degrees, we're going to subtract 90, and we're going to subtract 30, and that will give us angle X is equal to 60 degrees. Okay, next examples is classifying the triangles according to their angles as well as according to their sides. So we can classify these in 2 ways. So here we have 60, 60. This will also have to be 60. So this will be according to its angle. According to its angle, that is an acute. All 3 angles are less than 90 degrees. And according to its sides, it is an equilateral triangle. All right, question number 2. What do you guys think? All right, so this one here, based on its angle, that would be a right triangle. Oops, that's A. Based on its angles, that should be an A. And then based on its sides, it's going to be scalene. All 3 sides will be different. We have a 90 degrees, we have a 30 degrees, and then this would be 60, so this would be scalene. All right, and lastly, we have a triangle here with an angle that's greater than 90 degrees. So therefore, this is an obtuse triangle. And based on its sides, looking at its angles, all 3 angles are different. So this will also be scalene. All right, we'll come back and watch this video. Let's move on to quadrilaterals next. So quadrilaterals meaning 4 sides. So most polygons that have 4 sides, they're called quadrilaterals, but they will have special names, more specific. So here we already know a square. This is a square. All sides are congruent, all angles are 90 degrees, and opposite sides are parallel. In a rectangle, opposite sides are congruent. So these 2 are opposite sides, these 2 are opposite sides. All angles are 90 degrees, and the opposite sides are parallel. In a rhombus, it's like a tilted square. All sides are congruent, shown by the dashed lines. However, opposite angles are congruent. So this angle would be the same as this angle, and an angle here would be the same as this one here. So opposite angles are congruent, as well opposite sides are parallel. In a parallelogram, again, it's like a tilted rectangle. Opposite sides are parallel, these 2, and then these 2 sides. Opposite angles are congruent. This angle is the same as this one, this angle is the same as this one, and opposite sides are congruent. Here we have a trapezoid. It's a 4-sided figure. It just has 1 pair of parallel sides. So these 2 bases are parallel. And then if a figure doesn't fit into any of the categories above, then it's just called a quadrilateral. So this figure here doesn't fit into any of the specific names we just talked about. So we would just call it a quadrilateral because it is still 4-sided. Okay, so we are able to figure out measures of angles without using protractors based on everything we just talked about. Another method you can use is we can split a quadrilateral into 2 triangles just by drawing a line down. And that's another method. We know that one triangle, all the angles have to equal to 180 degrees. And if we split it down to make two triangles we know would have to equal to 360 degrees. So here we have 120 degrees, 90 degrees, and 90 degrees. So this angle we could calculate by taking 360 degrees, and then we'll subtract out 90, 90, and 120. So subtract out 90, minus 90, and minus 120 degrees, and that will give me angle X. So in this question, angle X therefore will equal to 60 degrees. Okay, in this example, looks like a parallelogram. We know that opposite angles are going to be congruent. So 45 degrees, 45 degrees, so 135 and 135. So we can say X is equal to 135 degrees, but we can still use the theory, what I said before. If we split this into 2 triangles is going to equal to a total of 360 degrees. So we can still do that method as well. So 360 degrees, subtract out 45, subtract the 45, and subtract the 135 degrees, and you'll still get the same answer, that angle X is equal to 135 degrees. All right, and then our last question here, this looks like a trapezoid, so we're just going to use our method of taking 360 degrees, and we'll subtract out those angles. Subtract 124, 60, and 63. And we get angle X here is equal to 113 degrees. And again, if you add up all four here, it will equal to 360